Okay, so we're in part two of Unit 6. It is pretty quick unit. It's only E and F here, so we're going to spend 1 day on E and 2 days on F. So we're on significant test for a population proportion. So specifically, today we're looking at confidence intervals for a difference in population proportion. So we've done confidence intervals for one single proportion. We're doing one for the difference. What are the conditions? So they're, again, pretty similar, just a few tweaks. I feel like that's what this is. Pretty similar, few tweaks. Random. So we want it to come from two independent random samples or from two groups of a randomized experiment. We don't see a ton of experiments with this, but if you do see an experiment, you have to talk about random assignment instead of random sample. But that would be okay. Sometimes we do deal with experiments, but typically it's random samples, and we need two separate independent random samples. Less than 10%, you have to check the condition for both proportions. So again, similar to what we've done before, large counts, you've got to check large counts, successes and failures for each proportion. So that's actually for n p hat and 1 minus p hat for the first proportion, n p hat and 1 minus p hat for the other one. They all have to be at least 10. So it's a lot of checking. It's just checking twice. Okay, so with more in-home viewing options, do people see movies in a movie theater less often now than in the past? I'm pretty sure that would be true. Gallup polled 800 randomly selected U.S. adults in 2001 and found that 66% had seen at least one movie in the movie theater throughout the whole year. So most people would see that. In 2021, they surveyed 800 U.S. adults and found that only 39% had been to the movie in the previous year. I wonder if, I don't remember what COVID was, but I wonder if that had an effect. Okay, so the proportion of the 2021 folks is the proportion of U.S. adults in 2021 who say they saw at least one movie in the theater. So we're defining the proportions. And I really like what they did there. Instead of calling it P sub 1, P sub 2, they called it meaningful names. So I really prefer you to use meaningful names like that with a subscript there. So you almost know what it is before you define it, right? So that's really good to use. I definitely prefer doing it that way. Check the conditions for calculating a confidence interval are met. So first, random samples. So they say something about 800 randomly selected U.S. adults in 2001, 811 U.S. adults found. So the second one, it doesn't say random sample. I think they meant to say random sample. If it was a random sample, then that would pass that condition. It's Gallup, and I know Gallup polls people randomly, so I'm going to trust that one here. Let's see, second condition, less than 10. So is less than 10% a condition? It is, right? So we have to check it for both groups. Okay, so is 800 less than 10% of all U.S. adults in 2001? I think so. Is 811 less than 10% of all U.S. adults in 2021? I think so. The last condition, if you look back at it, is large counts. Make sure to use p hat here for this one. And so we go, okay, so it would be 800 times 0.66. That's bigger than 10, I'm pretty sure. 800 times 0.34, that's bigger than 10. 811 times 0.39 and 811 times 0.61. Let's see. Oh, so interesting. So with the, I don't know if I mentioned that or not, so be sure to mention independent random samples, plural, from the population. So don't just say random sample, but independent. So you could actually maybe say that with 3 words, independent random samples. You have to use the plural if you do it that way, or you could do independent random sample from each one. I like the way they said that. It's actually pretty nice. And they use the plural of the word. So really just like you just got to be careful to communicate effectively that they know you're talking about both samples are independent and random samples in each year. Pretty similar to the way we were talking about there. And then the large counts, be sure that the counts of successes and failures are all at least 10. They should be rounded to the nearest integer. So that's interesting. It also helps you when you do here, if you do this in the calculator, which we'll eventually learn how to do, that'll really help to have that. So make sure you round them to the nearest integer. So you don't have to round up, just to the nearest integer. And they did both of those in the same line, but again, so actually they should have said 316 and 495 there would be better. Okay, they're all at least 10. Great. Okay, calculating a confidence interval for the difference between two proportions. So we're finding the difference between the two proportions. So the formula is a bit different. Instead of p hat in the middle, it's the difference of the two different p hats in the middle. Instead of just having one fraction underneath there, p times 1 minus p over n, it's two of them inside the square root there. We've seen that formula before for standard deviation when you have two proportions. So where z is the critical value for the standard curve. Okay, so z star, so similar, I think z star is calculated the same way. On the formula sheet, you only have these two formulas to kind of piece together the statistics. You have to realize we're doing a difference in proportions here is the statistics, that's p hat minus p hat, the one minus the other one, and then critical value is still the same, and then standard error, again, is this new formula, and that formula is on your sheet, so you have to kind of piece together. To get that formula, you have to piece together these two on the formula sheet. The generic formula, which doesn't really even say the difference there for statistics, but it kind of works and reminds you what to do. Okay, so calculate 95% confidence interval for the difference. The conditions have been verified. So assume the conditions are verified. We already verified these conditions. And so now we would just start plugging into the formula, right? So we take the proportions. You have to decide, we're doing 2021 minus 2001, right? So 2021, so we're doing 0.39 minus 0.66. So this will be a negative value there, I believe. 1.96, of course, we know how to do that. That's when you do the inverse norm for 95%. So you actually do inverse norm of 0.975, because 97.5 is to the left of the z-score there. And then you plug in the two separate n values, sample sizes, and separate proportions there into the same standard deviation formula there, and you work it out, and you get that. And so your two proportions. So those are both negative. That's interesting. So really, I think we'll get to this, but lots of times we're trying to figure out if zero's in that interval or not, because if there's no difference between the two, zero is going to be in the interval, right? If zero's in the interval, that's a plausible value. There's nothing going on here. Zero's not an interval. This tells us something. We got to figure out what it tells us. Does that mean we watch more or less movies now? But you got to think about that as to how you subtract it there, but you're going to use that. So, how do you do this on the calculator? So let's do the same one on the calculator here. So get your calculator out. Let me get it over here on the other side. Okay. So I'm guessing it's a similar location for the intervals. So menu 6, intervals seems to be number 6 there, and I think it sounds like a 2-prop z interval. So number of successes, we might have to go back to the other page. Let's go back to the page about successes here. Okay, here we go. So number of successes was 528. Wait, I got to make sure I'm doing the right one here. So let's see. So we wanted, which one do we want first? I have to look again. So 2021 is first. So I'm going to put 21 first. So 21 was the second one there. That's 316. So I'm going to put 316 out of 811. And 2001 is the second one. You're subtracting the 2001, so I want to put that second. So that's the 528 out of 800, I believe. And it's 95% level. That defaults there, and that's what we want, I believe. And so does it all. Let's see what we got. See if that matches, or it's close enough. So negative 0.317. It's pretty solid. Negative 0.223. And it gives us the margin of error there if you want it. It gives us the difference, p hat, the difference p hat difference, I think there is what it's saying. And so that's negative 0.27. It gives us really all the values there, which is very nice. So we got that. Okay. Often leads to calculation errors by students. As a result, your students may recommend using 2-prop Z interval or the 2-prop, yeah, sure. If you go this route, make sure to include 3 steps: state, plan, and conclude. You have to kind of do on your own. But the do part, make sure you just provide the interval. So you don't have to provide the calculator step you did there. You just have to provide the interval is correct for the do step. That's the only requirement. It's kind of nice, right? So this is nice, especially if you're kind of haven't done 2-prop Z interval in a while. You go, okay, let me just do this do step on the calculator, get the interval, and move on. So, but while you're learning, definitely plug in all the numbers. It's going to help you in the multiple choice section. It's going to help you understand what we're doing, help you understand the Z-scores, the differences, so forth. So the percentage, and this is what's interesting about, this is what's really interesting actually about intervals. It tells us more information than a test does. A test just tells you kind of yes or no. Yeah, there was a difference. An interval, this is what it tells us. So there is the percentage of U.S. adults who saw a movie during the previous year decreased by between 22.3% and 31.7%. Or percentage points from 2001 to 2021. Oh, they said percentage points. It's interesting. So don't say percent when you mean percentage points. A decrease of between 22.3 and 31.7 percentage points is not the same as a decrease of that percent. So we'd like to say percentage points here when you're communicating effectively and accurately. It's really easy to forget that, by the way. I don't think that's a huge ding on there. If it is a ding, sometimes they overlook that on the rubric, but that's the idea. So oftentimes the true proportion, who had surgery and survived, that would be talking about a sample or something that happened in the past. So you want to talk about the parameter. So be careful with your verbiage there. And finally, 2-sample Z interval for difference is used to estimate the difference in proportions between the successes of 2 populations of treatments. Okay. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs, NSAIDs, like naproxen to ease their pain. Researchers wondered if taking Valium along with naproxen would affect the pain relief. To find out, they recruited 112 patients with severe low back pain, assigned them 1 of 2 treatments, either the naproxen or the Valium, or naproxen and a placebo. Oh, okay, so they give you naproxen no matter what, but do you get the Valium or not? Wow, okay, so after 1 week, 39 of the 57 who took naproxen reported lower back pain, reduced lower back pain, and then 43 of the 55. Construct and interpret a 99% interval for the proportion. Okay. Be sure to indicate the order of subtraction. That is important, right? You can do either order. It's okay. You might get a negative or positive answer based on what order, but it doesn't really matter, the order. Okay, so for the state section, you want to talk about, we're doing a 99% confidence level. We're doing the difference and stated the order. So naproxen Valium is NV and naproxen placebo is NP. Therefore, I like that description. And you find what both of those are. That's called defining the parameters. So you have to define both parameters here. Sometimes they accept it if you just have the NV, like if you label them with meaningful labels, that sometimes work. On the rubric, so it kind of depends. So this is a 2-sample Z interval for a difference in proportions, or a 2-prop Z interval if you want to shorten that. Randomly assigned patients take naproxen Valium or the other one. It does probably say that, I think. I don't see where it says random, but maybe I'm missing it. They recruited 112 patients. Okay, and randomly assign them to 1 of 2 treatments. Okay, so they did randomly assign them to one of the treatments. So this one, oh, I like this. So this is an experiment. It even says the word randomly assigned. So instead of saying random sample, which we're used to saying, if you're not thinking, you're going to say random sample here, random assignment, right? So randomly assigned because this is an experiment. So this is the first one we've done with the experiment. Large counts condition. So it kind of tells us the large counts. There were 39 successes, which means 18 failures in the first one, and 43 successes, which means 12 failures. So you could multiply out the n times p hat here, or just grab the number of successes and fails. It seems easier to grab the number of successes and fails here, but all those are at least greater than or equal to 10. So this is an interesting little factoid, which we have not talked about before. So when it's an experiment, you're not sampling without replacement. That's the less than 10% condition is proving independence. And so you can just skip that step if it's an experiment. You don't have to do less than 10%. In fact, I would advise probably not to do the 10%. That's really high end right there. If you remember to, oh yeah, I don't have to check the less than 10% condition because we're not sampling without replacement. We're doing an experiment. I like this example that we had one like this to show you this. So construct and interpret that. So for the do, if you're showing your work, you want to show both p-hats, use the equation, plug in the numbers there, and find the values. Definitely double check. If you haven't learned from the last chapter, please learn now. You want to do the double check. You want to do the 2-prop z interval in your calculator for sure. If I go back to what the difference is, it tells us there. So let's just do this in the calculator and see if we get the same answer. So just double check our work here, right? So menu 6, 6, and it's 2-prop z interval. So 6, 6, 6, 6. Whoa, whoa, menu 6, 6, 6. Hopefully you're not too superstitious here. The order was, I guess we're doing NV first. So NV was 39, was the number of successes out of 57. I like the way it's laid out with these. And then 43 out of 55. And it was 99, so 0.99. Oh, it's so easy to do, really. Lower bound, negative 0.311. I'm pretty sure we got that the same. Yeah. It's slightly different because of rounding, but it's the same answer. Using a calculator, we get a slightly different answer. That's fine. Conclude, we are 99% confident the interval from blank to blank captures the true difference in the true proportions of patients like the ones in the study who would be reported. So we're talking about the difference in the order there. So make sure you say the true difference in proportions is the key wording there. Based on the confidence interval you just found. So what we found, ooh, interesting. So 0 is in the interval. That's a plausible value. I don't think we can't prove there's a difference here. I don't think. Let's see what they say. Based on the confidence interval, what conclusion can you make? Well, because the intervals include 0 as a plausible value, we don't have convincing evidence that taking Valium along with naproxen affects pain relief for patients like these. So we don't have that kind of evidence there. So you're really lots of times looking for is 0 in the interval or not when you're doing a difference in proportion. And then they went on to say, like these report reduced pain is between 31.4 and 11.62 lower and 11.62 percentage points higher. Again, percentage points is how we want to talk about these differences with this. Never suggest you believe the difference is 0. You're saying it's a plausible value, so we don't have enough evidence to prove there's a difference. That's the end of the lesson, but let's just look at a couple examples here. If you want to do these for extra practice, stop it, look at it, and check out the solutions for the intervals there. And then this one, do the do step there, good practice for you. And finally, construct the interval for this one and the do step in the whole 9 yards, and you got it. Again, that's if you want extra practice. And they went on to ask a question about the answer. What does that mean in that case? Because the interval doesn't include 0, We have convincing evidence. So if it doesn't include 0, we do have convincing evidence that there would be between an 8.8 percentage points and 12.345 percentage points difference or advantage for one than the other there in that setting. Thanks. That's your lesson for today.